Hello dear students, all of you welcome to Vidyan classes. Today we will discuss the 10th property of inverse trigonometric functions and its application. E10, property number 10. For x plus y greater than equal to 0, where x greater than equal to minus 1 less than equal to plus 1, y greater than equal to minus 1 less than equal to plus 1, cos inverse x plus cos inverse y is equal to cos inverse xy minus square root of 1 minus s square into 1 minus y square. For x plus y greater than equal to 0, where x greater than equal to minus 1 less than equal to plus 1, cos inverse x plus cos inverse y is equal to cos inverse xy minus root of 1 minus s square plus into 1 minus y square. Second bit, for x plus y less than or equal to 0, x greater than equal to minus 1 less than equal to plus 1, y greater than equal to minus 1 less than equal to plus 1, cos inverse x plus cos inverse y is equal to 2 pi minus cos inverse xy minus root of 1 minus s square into 1 minus y square. For x plus y less than or equal to 0, where x greater than equal to minus 1 less than equal to plus 1, y greater than equal to minus 1 less than equal to plus 1, cos inverse x plus cos inverse y is equal to 2 pi minus cos inverse xy minus root of 1 minus s square into 1 minus y square. Third bit, cos inverse x plus cos inverse y is equal to cos inverse xy minus root of 1 minus s square into 1 minus y square. Cos inverse x plus cos inverse y is equal to cos inverse xy minus root of 1 minus s square into 1 minus y square if x less than or equal to y. And cos inverse x, it is minus, it is plus. Cos inverse x minus cos inverse y is equal to cos inverse xy plus root of minus of cos inverse xy plus root of 1 minus s square into 1 minus y square if x greater than equal to y. Cos inverse x minus cos inverse y is equal to cos inverse xy plus root over of 1 minus s square into 1 minus y square if x less than or equal to y, and cos inverse x minus cos inverse y is equal to minus of cos inverse xy plus root over of 1 minus s square into 1 minus y square if x greater than or equal to y. Proof. Let us prove cos inverse x, that is the first bit. Let us prove the first bit. Proof is not necessary for the exam. Cos inverse x plus cos inverse y is equal to cos inverse xy minus root over of 1 minus s square into 1 minus y square. For x plus y greater than equal to 0, x greater than equal to minus 1, less than equal to plus 1, y greater than equal to minus 1, less than equal to plus 1. Let cos inverse x is equal to a and cos inverse y is equal to b, which implies by x is equal to cos a and y is equal to cos b. Since cos so that close bracket 0 pi to close bracket minus 1 1 close bracket is invertible. That means the inverse is exists, implies by cos inverse so that close bracket minus 1 1 to close bracket 0 pi close bracket. Cos function is invertible when it is defined from this set to this set. Cos inverse x is equal to a, x is equal to cos a, cos inverse y is equal to b, y is equal to cos b, where a, b belongs to close bracket 0 pi close bracket. A greater than equal to 0, less than equal to pi, b greater than equal to 0, less than equal to 2 pi. Implies this a plus b less than equal to 2 pi greater than equal to, the minimum value of a and b is 0, so the minimum sum is 0, the maximum value of a and b is pi, so a plus b is 2 pi. Implies this a plus b greater than equal to 0, less than equal to 2 pi. Cos a plus b is equal to cos a into cos b minus sin a into sin b, which is same as cos a is equal to x, cos b is equal to y. Cos a into cos b minus sin a can be written as root over of 1 minus cos square. 1 minus cos square b. It is xy, cos a is equal to x, cos b is equal to y. 1 minus of s square into 1 minus y square, which implies cos a plus b is equal to xy minus square root of 1 minus s square into 1 minus y square. It is taken as equation 1. To show cos a plus b is invertible. To show cos a plus b is invertible. That means the inverse of this is exists. Clear? Cos a plus b is equal to this. Cos a is sin a is written as root of 1 minus cos square a. Sin b is written as root of 1 minus cos square b. Cos a and cos b are x and y. Put in this cos a is equal to x, cos b is equal to y. We will get this result. Cos a plus b is equal to this. Now we have to show cos a plus b is invertible. That means the inverse of the function is exist. Again we have x plus y greater than equal to 0, which implies x equal to cos a, y is equal to cos b greater than equal to 0, which implies cos a greater than equal to minus cos b, which is same as cos pi minus b. Cos pi minus b is equal to minus cos b, which implies pi minus b greater than or equal to a. Cos a is greater than equal to this, pi minus b greater than or equal to a. Since cos is decreasing, cos is decreasing on close bracket 0 and pi, which implies pi greater than equal to a plus b, which implies a plus b less than equal to pi, also greater than equal to 0. Since AB belongs to close bracket 0 pi close bracket. Pi greater than equal to a plus b or a plus b less than equal to pi. Since a belongs to close bracket 0 pi close bracket, the minimum value of a plus b is 0 or greater than 0, which implies a plus b belongs to close bracket 0 pi, which is same as range of cos inverse. The range of cos inverse is equal to this. So cos inverse, cos is invertible in this, cos is invertible on this interval. That means which implies cos a plus b is invertible on close bracket 0 pi close bracket. Since a plus b belongs to this, it is the range of cos inverse. That means cos a plus b is invertible. Equation 1 implies this. Equation 1 implies a plus b. Since cos a plus b is invertible, we can write a plus b is equal to cos inverse xy minus root of 1 minus s square into 1 minus y square. Since cos a plus b is invertible on close bracket 0 pi. What is a? A is equal to cos inverse x. What is b? Cos inverse y. Therefore, a is equal to cos inverse x, b is equal to cos inverse y, which is same as cos inverse xy minus root of 1 minus s square into 1 minus y square. Hence proved. So the first bit is proved. Similarly, we can prove second bit and the third bit. Similarly, we can prove second bit and third bit. Proof is not necessary for the exam. You should memorize all the properties to solve the problems. Proof of the property is not required since proof is not coming in the exam. Clear? Clear? Okay, note down. Application. First bit, cos inverse minus 7 by 25 plus cos inverse 3 by 5 is equal to dash. Cos inverse minus 7 by 25 plus cos inverse 3 by 5, which is same as pi minus cos inverse 7 by 25 plus cos inverse 3 by 5. Since cos inverse minus x is equal to pi minus cos inverse x. Clear? Cos inverse minus 7 by 25 is equal to pi minus cos inverse 7 by 25. Since cos inverse minus x is equal to pi minus cos inverse x, which is same as pi minus cos inverse 7 by 25 minus cos inverse 3 by 5. X is equal to 7 by 25. Y is equal to 3 by 5. 35 less than 75. 35 less than 75. 7 into 5 that is equal to 35. 25 into 3 that is 75. So y is greater than x. Implies cos inverse x minus cos inverse y is equal to cos inverse xy minus root of 1 minus s square into 1 minus y square. Since x less than y, cos inverse x minus cos inverse y is equal to cos inverse xy by the third formula. Here pi minus cos inverse x into y, that is 21 divided by 125 plus root of 1 minus 49 by 625 into 1 minus 9 divided by 25, which is same as pi minus cos inverse 21 by 125 plus 24 by 25 into 4 by 5, which is same as pi minus cos inverse 21 by 125 plus 96 divided by 125. Clear? Which is same as pi minus cos inverse 117 divided by 125 is the answer. Using this formula, we get pi minus cos inverse 117 divided by 125. Clear? Since x less than y, if x less than y, cos inverse x minus cos inverse y is equal to cos inverse xy plus root of 1 minus s square into 1 minus y square, which gives pi minus cos inverse 117 divided by 125. Second bit, answer cos inverse 3 by 5 minus cos inverse 7 divided by 125. Since x is equal to 3 by 5, y is equal to 7 by 25, it is greater than 25 into 3, that is 75, greater than 35. Implies cos inverse x minus cos inverse y is equal to minus cos inverse xy plus root of 1 minus s square into 1 minus y square. By the third formula, since x greater than y, we will use minus cos inverse xy plus root of 1 minus s square into 1 minus y square, which is same as minus cos inverse xy, that means 21 divided by 125 plus root of 1 minus 9 by 25 into 1 minus 49 divided by 625. Clear? Okay. Minus cos inverse 21 divided by 125 plus 24 divided by it is 24 divided by 25 into it is 4 by 5, which is same as minus cos inverse 117 divided by 117 divided by 125. So this result is minus cos inverse 117 divided by 125. Clear? Okay. Third bit. Cos inverse 7 divided by 25 plus of cos inverse minus 3 divided by 5, which is same as cos inverse 7 by 25 cos inverse minus x is equal to pi minus cos inverse 3 by 5. Cos inverse minus x is equal to pi minus cos inverse x, which is same as pi plus cos inverse 7 by 25 minus cos inverse 3 by 5. Here x is equal to 7 by 25. Y is equal to 3 by 5. 35 less than 75, which gives cos inverse x minus cos inverse y is equal to cos inverse xy minus plus root of 1 minus s square into 1 minus y square, which is same as pi plus cos inverse 21 divided by 125 plus root of 1 minus 49 divided by 625 into 1 minus 9 by 25, which is same as pi plus cos inverse 21 divided by 125. This result is 96 divided by 125. This result is 96 divided by 125, which is same as pi plus cos inverse 117 divided by 125. It is the answer. Clear? Clear? Okay. Note down. Next, elements of mathematics, page number 65, question number 12, first bit. Cos inverse x by a plus cos inverse y by b is equal to theta. Prove that s square by a square minus 2xy cos theta whole divided by ab plus y square by b square is equal to sin square theta. Prove cos inverse x by a plus cos inverse y by b is equal to theta, which implies this. Cos inverse x plus cos inverse y is equal to cos inverse xy. Xy means x by a into y by b. It is x, it is y. Minus root over of 1 minus x by a whole square into 1 minus y by b whole square is equal to theta. It is assumed that x by a plus y by b greater than or equal to 0, which implies this xy divided by ab minus root over of 1 minus s square by a square into 1 minus y square by b square is equal to cos theta. Clear? Cos inverse this is equal to theta. This value is cos theta, which is the same as xy divided by ab plus cos theta minus cos theta is equal to square root of 1 minus s square by a square into 1 minus y square by b square. This minus this is equal to this. Squaring both the sides. Squaring both sides, it implies s square y square divided by a square b square plus cos square theta minus 2 xy cos theta divided by ab is equal to 1 minus s square by a square into 1 minus y square by b square. Squaring both the sides, it gives this result, which implies s square y square divided by a square b square plus cos square theta minus 2xy cos theta divided by ab, which is same as 1 minus y square by b square minus s square by s square by 1 minus y square s square by a square plus s square y square divided by a square b square. S square y square divided by s square y square divided by a square b square cancel, which implies we have to show s square by a square, which implies s square by a square minus 2xy cos theta divided by ab is plus y square by b square is equal to 1 minus cos square theta, which implies s square by a square minus 2xy cos theta divided by ab plus y square by b square is equal to sin square theta. S square by a square minus 2xy cos theta divided by ab plus y square by b square is equal to sin square theta, hence proved. Hence proved. Clear? Okay, note down. Question number 12, second bit. If cos inverse x by 2 plus cos inverse y by 3 is equal to theta, prove that 9s square minus 12xy cos theta plus 4y square is equal to 36 sin square theta. Important. Given cos inverse x by 2 plus cos inverse y by 3 is equal to theta, which implies cos inverse xy divided by 6 minus root of 1 minus s square by 4 into 1 minus y square by 9 is equal to theta. Since cos inverse x plus cos inverse y is equal to cos inverse xy minus root of 1 minus s square into 1 minus y square. If x plus y greater than equal to 0, x greater than equal to minus 1, less than equal to plus 1, y greater than equal to minus 1, less than equal to plus 1. Here x is x by 2 plus and y is equal to y by 3. It is assumed that x by 2 plus y by 3 greater than or equal to 0. And this value is less than equal to the mod of x by 2 less than equal to 1, mod of y by 3 less than 1, which implies xy divided by 6 minus root of 1 minus s square by 9 into 1 minus y square by 9, it is 4, is equal to cos theta. Cos inverse this is equal to theta, this value is equal to cos theta, which implies xy divided by 6 minus cos theta is equal to square root of 4 minus s square into 9 minus y square divided by 36. Which is the same as xy minus 6 cos theta divided by 6 is equal to 36 minus 4y square minus 9s square plus s square y square divided by 6. 6 cancel. Squaring both the sides. Both sides. It gives xy minus 6 cos theta whole square is equal to 36 minus 4y square minus 9s square plus s square y square. Clear? Okay. Which implies s square y square minus 6 into 2, that is 12 xy cos theta plus 36 cos square theta is equal to 36 minus 4y square minus 9s square plus s square into y square. S square y square cancel, which implies this. 9s square. 9s square minus 12 xy cos theta plus 4y square is equal to 36 minus 36 cos square theta, which is equal to 36 taking common 1 minus cos square theta, which implies as 9s square minus 12xy cos theta plus 4y square is equal to 36 sin square theta. 1 minus cos square theta is equal to sin square theta. Hence, proved. Clear? Okay. Note down.